Hello everyone. This video will be going over Edmentum Geometry Semester B, Unit 9, Course Activity, Explaining Volume Formulas. The task 1 begins on page 7, and that's where we will be beginning. This task has to do with volume of a cylinder, and it states, in this activity, you'll apply your understanding of the volume of a rectangular prism to find the volume of a cylinder. Question 1 begins with, consider this cylinder and rectangular prism, which have been filled with unit cubes. Complete each part of the activity to derive the formula for finding the volume of a cylinder. So keep this in mind. We are going to be finding the volume of a cylinder throughout this whole uh, question 1. So as we proceed, please keep that in mind. So part A asks us to suppose the bottom surface or base of a cylinder is divided into 16 congruent sectors. The sectors are rearranged as shown. So we have our circle cut into different parts, and they're rearranged to form this shape. And we're meant to open our GeoGebra activity to divide the circular into even more sectors and rearrange them for ourselves. We'll get to that in a bit, but let's continue on with the question. We're supposed to complete the statements below, essentially. So we'll read through this in a moment, but again, let's go ahead and jump to the end and see that it says, so there are, so excuse me, so the area of the circular base is blank square units. So in this part A, what they're asking us to find is the formula for the area of the circular base, or in other words, the area of a circle. So some of us may already know what the area of a circle is, the formula that represents that. But this problem is going to take us through how we find that formula, how we derive it. So let's explore. So when the sectors of the circle are rearranged, they close to forming A. Well, looking at our shape that they're given here, this resembles most a rectangle. So now let's go ahead and open our GeoGebra page to see exactly what's going on. So first it gives us this slide in order to extend out the circumference. So we should remember from past activities that the equation for the circumference of a circle is equal to 2 pi r. So the circumference is the length of the outside of the circle. So it's 2 pi r here. When extended out, it's still 2 pi r in length. So it dissects our circle here and puts into 12 parts and lays it out, each of those parts out, so that they align with the circumference once more. So here we have a length of 2 pi r. But when they fold in on one another, again, they form our rectangular shape. And now we see that they extend to only half the circumference length. So essentially, they only extend pi r in length. And you might say, like, hey, we this doesn't resemble a rectangle exactly. Uh, we don't have justification for calling this a rectangle. And that's a fair criticism until we realize we can dissect it into more than just 12 parts. If we raise this and we dissect it into more and more parts, and we rearrange it like we did before and fold it in on itself, it very much resembles a rectangle here. So that's our justification for being able to call this a rectangle and using the rectangle formula to find this area. Because, again, this is a circle, but we're able to now put it in terms of a rectangle. So we could use the formula for the area of a rectangle in order to find out the area of a circle. So let's go ahead and keep going here. So they are close to forming a a rectangle with a length of, well, what's the length here? Well, it's half our circumference, so it's pi r. With r, excuse me, with a length of pi r units and a width of r units. Our radius hasn't changed, so our radius now turns into the height of our rectangle. So our base is pi r, our height is r, or our width is r. So ultimately, our equation is going to be pi times r, or pi r squared. So the area of the rearranged figure is equal to that of a circle. So the area of the circular base is pi times r, or pi r squared. So for part B, it tells us, considering the results from part A, it follows that the volume of a cylinder can be found the same way as the volume of a rectangular prism. Use your results about and what you know about volume to explain how to find the volume of a cylinder with a base radius of r and a height in h. So let's remind ourselves of what the formula for a rectangular prism is. So the formula for the volume of a rectangular prism is functionally, well, we'll get into the function in a bit, but it's length times width times height. But another way of looking at this is that this is equal to the base times height. However, your base, since this is a 3D shape, is going to be a two-dimensional space. It's going to be an area. So if you have a rectangle, or excuse me, a rectangular prism, I'm no artist, so I'm just doing my best. Our base is going to be this bottom piece. This is our base. And of course, we have our length and width. But what we're doing is we're finding the area of our base side here. And we're multiplying it by our height. So this is essentially what a rectangular prism formula for volume is. Now let's look at our cylinder situation. So let's reverse engineer this. So we have our base and we have our height. So our volume formula is going to be the same thing as over here, but rather than doing length times width, I'm going to use the base times height version of this formula. Our base this time is the area of a circle. And the area of a circle we have determined, or we remember, is pi r squared and times our height. Let's make this a capital H for consistency. And this is going to be our volume for a cylinder. So that's how we derived it, and this is what it is. So whenever you need to reference a volume for a cylinder formula, is going to be pi r squared times the height of the cylinder. And so you're going to write something akin to that in this box, that the volume formula for a rectangular prism is base times height, and it's going to be the same thing for a cylinder now. You just need to use different formulas for the base of both objects. Moving along, question 2 gives us the situation. Juanita makes a stack of pennies 38 millimeters tall. Each penny has a diameter of 19.05 millimeters. What is the volume of the stack of pennies? Well, luckily we remember our formula for volume, and this just becomes a plug-in game. So what we're going to do is we're going to take we are going to remind ourselves of what the volume for a cylinder is, and that is the volume is equal to pi times r squared times the height of the cylinder. So from here, it just becomes the plug-in game when we plug in for our values. So pi is going to remain pi. Our r is going to be half the distance from one side of the pen to the other. So that's going to be 19.05 divided by 2, which seems to be 9.525. And of course, we're going to square that. Times h. And of course, our h is 38 millimeters. So if we multiply all that, let's see what we get. That seems to be quite a large number. But rounding to the nearest whole millimeter, that is going to be 10,831. And that is all for question 2, part A. Moving on, we go to question 2, part B. And what this tells us to take a look at is what happens if the table holding one of these pennies gets bumped and the stack becomes slanted? How is the volume affected? And of course, to explain your reasoning. So, to answer this question, we need to understand what a volume is, what volume means. And what it means is volume is the space occupied within the boundaries of a three-dimensional space or three-dimensional object. So it's the space that the cylinder takes up. So how is the volume affected? Well, it's not. The volume of the stack is not affected because the space that the pennies take up haven't changed. Nothing has made the pennies grow or shrink, or you didn't take away a penny or add a penny. So the space that the stack takes up is the same. It just looks different. It's just slanted now. And we could actually use that in future questions. If it tells you to take a area of a slanted cylinder, it's going to be the same thing as taking the area, or excuse me, the volume of a uh, upright cylinder. So you're going to put something like that the volume is not affected. And explaining how you know that is just by stating what you know volume to be. And that's not affected by any shifting left or right. It's only different if it takes up more or less space. And with that, I do believe that brings us to the end